Hello and welcome to Chapter 3. Chapter 3, we are going to discuss link aggregation. Link aggregations means that we are going to have several ports on a switch that are going to be aggregated, bundled together when they are connected to another switch. They are going to give us higher bandwidth. So instead of having 100 megabits connected to as a trunk to another switch, we're going to have maybe 5 or 6 or even up to 800 megabit connection. There are two different protocols as we've seen just earlier. There is the link aggregation protocol that is going to be done. There's a protocol that is Cisco proprietary called the link aggregation protocol. We'll take a look at that. Then we're going to create a packet tracer. By the way, that will take care, that will do that. We'll do that together towards the end. And we're also going to do the IEEE 802.AX, the link aggregation control protocol, which is the most commonly used. We'll configure that as well. And we'll see how to do both. All right, both of these are really what is called on the ether channel. So an ether channel is a bundled up of ports together that are going to be connected to also give us more bandwidth and for redundancy as well. All right, so we'll talk about that as we move along. All right, so let's begin. So what is link aggregation again? I already explained it, but we'll go over it one more time. By the way, before I begin, a couple of things. Uh, Packet tracer is what you need to hand in for this lab. Okay, so please make sure that you go over that when we get to towards the end. This should be a very short lecture, so if I don't get to talk too much, we're going to breeze right through it. And most of the time we'll be spending on uh, building and configuring Ether channel using the protocol aggregation protocol and the LACP. Okay, so again, all right, let's begin. So what is an Ether channel? An Ether channel is when you bundle up several ports and they will be connected to the other switch. Now, the advantage of bundling, aggregating ports is that if any of the link breaks, the other one just keeps going. The switches sees all of these ports together as one link. So if one link breaks inside, we call it a channel. So all these links bundled up together is called an ether channel. If one link inside that channel breaks, STP doesn't see that as the whole, doesn't see it as a channel going down. So instead of having 500 megs, you'll have 400 megs. That's all it does. So STP will never have to bring down and try to recalculate and figure out another connection. So you guaranteed almost constant connection, number one. And number two, the link aggregation allows you to have higher bandwidth, of course, especially if you have ports that are not being used. Okay, so having an ether channel is great. You can't beat that. All right. The only disadvantage is you're using up ports, but most likely the ports are not being populated, especially the ones at the distribution layer. All right. So the advantages, like I said, we don't need any additional ports. We don't have to buy any new switches or upgrade the ports to gigabit Ethernet. We'll use what is already what we already have and just pick up the ones that we're not using. And they don't have to be in consecutive order. So for example, you can pick port 1, port 5, port 11. Those three ports could be a channel by themselves. Okay. So again, STP sees it as one logical link. So if any of these ports go down, STP will still be running. So that gives us redundancy too, in addition to load balancing. All right, so you're grabbing a whole bunch of ports, bundling them up together, and that's what's called an ether channel. You can have up to 8 ports bundled on these Ethernet 28, 29, 50 switches. Now with the newer operating system, you can have a little bit more, but for now, our switches handle up to 8 ports at a time. So that gives you, if they are fast Ethernet, which means they're running at 100 megabits per second, that means you're going to get an ether channel that gives you up to 800 megs. If they gigabit Ethernet, you can get 8 gigs. So that's not bad. All right. So The first protocol we'll go over is the port aggregation protocol. This is a Cisco proprietary protocol. So as we will see, we're gonna get the get the ports together, and then if this channel is on and the other one is on, the channel on, then the link, then you have a link between the both. Then the channel is established. If this one is desirable, and the other one has to be on or desirable for you to have a channel. Otherwise, you will not have a channel no matter what. So it's either on, desirable, desirable, or desirable auto. You can't have auto. It won't work. Okay, we'll talk about that when we do the configuration. The link aggregation control protocol. This is the open, you think, the IEEE one, the 802 dot. It used to be called AD, lowercase AD at the end, 802.3 AD, but they changed it to 802 dot capital A, capital X. Pretty much the same thing. It works. If this channel is on and this channel is on, then you have a channel between them. Okay, and if this is, then they use the word active, and this has to be passive or active, and then we're good to go. Otherwise, it will not, you will not have a channel. Again, we'll see how we do that when we do our configuration. All right, and bingo, now we go to the configuration. So before we actually get to the packet tracer, a couple of things do you need to remember. Ether channel must be supported by both switches. So obviously if the software, if the operating system on the switch doesn't support Ether channel, you're not going to have one. The speeds and the duplex mode on the ports on the switches must match. So if they are full duplex or half duplex, the other side must be half duplex or full duplex. If they are 100 megabits, the other side has to be, they all have to be 100 megabits per second in terms of speed. The VLANs have to be the same, and the range of VLANs has to be the same on all the interfaces. Okay? All right, so why don't we just go, and this is how you do the LCAP, and we're going to get to this right on. So might as well, actually, this is it for the chapter, believe it or not. Now we're going to go to Packet Tracer and see how this is done. And the best way to do it is, of course, to open up a Packet Tracer. And when you open up a Packet Tracer, this is what we're going to do. Bring in, let's say, bring in 3 switches. Let me put my glasses on because I can't see this. And bring in a 2960 switch, 3 of them. 1, 2960 switches, 3 2960 switches, and set them up this way. Actually, I'm going to do something that is similar to a lab towards the end of the chapter. And here what we're going to do. We're going to call this S1. Change the label on this S1. Change the one and call that S3 because S2 is going to be on the bottom. And leave this, oops, sorry. Make this switch S2. Okay, so we got S1, S2, S3. Okay, and here, let's go to connection. You can, by the way, use a straight through cable because of the MDIX on the switches will allow that. But let's go with straight crossover cable. Connect port 4 to port 4 of S3 and get another crossover. Connect port 3 to port 3 on switch 3. What the hell? What did I do? Connect 4 to 4. Oh, I made a mistake. I want to make sure they are. This one should be to 4, and then 3 to 3, and this one 3 to 3, and then go from switch 1 to switch 2. Switch 1, do 1 to 1, and 2 to 2, and then go from 1 to 3, and go from 2 to 4. It really doesn't matter which ports you pick, to be honest with you. You just need to remember when you are bundling them, which one's which. And you can see STP is running, right? As you can see right here. So bring in 3 PCs. Let's put 1 PC right here, another one right there, and another one right here. Let's call this PCA, and call the one on the bottom PCB, call the one on the top PC3. This will be a good PCC. Oh, PCC is good. What the hell? Okay. Now I want you to connect this one to port 6 of switch 1, port 6. Connect PCB to port 18. And connect. Oh, these are not good. We got to use crossover cable. What am I doing? Crossover cable to port 18 of switch 3. So I got to take these two guys out. No, what? Oh my God. You see? I'm getting old. It is a straight through cable. Fast Ethernet to 18. Okay? All right, here's what we're going to do. I'm going to just put a little text file on the top and say I'm going to do P port aggregation protocol up here. I'm going to do LACP here, and this is going to be port channel 2. This one is going to be, oops, this one is going, you know what, let me take that out because this one is going to be port aggregation protocol. This is going to be power channel 1. This is just for my information. If you don't want to do that, that's fine. This is going to be LACP. This is going to be port channel 3. You'll see what I'm talking about later on. All right, so we're all set with setting up the devices. So here's what we're going to do next. Let's do the configuration. You know, I don't know. Okay, here's what you should do when you're all set up. Go to the switches and shut down all the interfaces that are not all the interfaces and only enable the ones that are connected to the PCs. So if I go to switch 1, well, what we're going to do first, obviously, is do the regular setup. Do EN, config T, no IP domain, lookup, and then host name S1, and you're going to go interface range FA0/1 to 24, and I'm going to do shut down. So they're all closed now. And then I'm going to go to interface fast Ethernet 06 and open that up. No shut. Okay, let's go to switch 2. Do the same thing. Do EN, config T, no IP domain. Lookup, and the host name S2, and go to interface range FA0/1 to 24 and do shut on all of them, and then go to interface fast Ethernet 0/18 and type no shut. Excuse me. Okay, let's go to switch 3 and do pretty much the same thing. EN, config T, no IP domain. Lookup, and a host name of S3. And go to interface range FA0/1 to 24. Do a shutdown, and then no shut. No, then you go to interface fast Ethernet 0/18 and you say no shut. Okay, excuse me. All right. So that's that. So now these are enabled to PCs. Now I want to go to each PC and create a VLAN 99 because that's going to be our native VLAN and the management one. Excuse me. And I'm going to make VLAN 10 where the PCs are going to be, all three PCs are going to be in VLAN 10. So let's do that. So let's go to switch, starting with switch 1. Say VLAN 99 and the name is MGMT and native, right? And I'm going to say VLAN 10 and the name is going to be staff. And then I'm going to take interface fast Ethernet 0/6. And I'm going to say, excuse me, let me get a drink. Okay, that's a little bit better. Okay, you go to port 06 and you say switch port mode access and then switch port access to VLAN 10. All right, let's go to port switch 2, create VLAN 99, and then you're going to say the name is MGMT and native. Then you're going to go to VLAN 10 and the name is going to be staff. And then I'm going to go to interface fast Ethernet 0/18 and I'm going to say switch port mode access. You know what that means? That means the port went from dynamic to access. Access ports mean they are data ports. That means they are going to be connected to workstations, any device that is going to be sending them data, workstations or printers maybe. All right, then you say switch port access, take that port and send it to VLAN 10. All right, let's go to switch 3 and say VLAN 99 and the name is MGMT and native. Okay, and let's do VLAN 10. The name is staff. And then I'm going to go to interface fast Ethernet 0/18. Switch port mode access. And then switch port access to VLAN 10. All right, so we are familiar with all of this stuff, right? Now I'm going to assign the IP addresses. Here's what I'm going to do. Let me minimize this. Excuse me. I'm going to go with the network 192.168.10.0, as we always do, /24 for everybody. PC1 is going to get .1, PCA. PCB, I'm going to give him .2. PCC, I'm going to give him .3. Switch 1 is going to be .11. Switch 2 is going to be .12. And switch 3 is going to be .13. All right, so here we go. Let's connect. We don't have to do any subnetting today. Go to the PC, PCA, desktop, and it's 192. Oops, not typing. 192.168.10.1. Hit the tab key and you're done. After /24. Go to PCB. 192.168.10.2. Hit the tab key. Go to switch 3. 192.168.10.3. Hit the tab key. Now let's go to the PC and go to interface VLAN 99. That's where you give the IP address because that's the management and the native VLAN, right? Remember? And you say IP add. You don't have to type no shut, by the way, at the end. 192.168.10.11 space 255.255.255.0. Okay, excuse me. And the best, you know what we should do? Do Control Z and do then copy, run, start. This is the basic configuration. Hit enter, enter. So we save our configuration file in the NVRAM. Let's go to switch 2 and say interface VLAN 99, IP add 192.168.10.12, space 255, 255, 255, 2.0, Control Z, and then copy, run, start. Enter, enter. And then I go to switch 3. And then I say interface VLAN 99. The IP add is 192.168.10.13. Space 255, 255, 255.0. Control Z, copy, run, start. So everything that we did is the basic configuration. All right, now here we go. Now we are going to bundle up ports 3 and 4 into one channel. So you'll have 200 megabits connecting both ways. And of course, we have to activate these ports, do a no shut on them. All right, so here's how you do it. You go to switch 1. This we're going to do the protocol aggregate port aggregation protocol, right? And you're going to use channel 1 for them. So I'll click on switch 1, and here's what you do. Config T, and you go to interface range, and you say, I want FA0/3 to 4, those 3, right? And then you're going to say, all right, channel dash group, please put these in a group, put this channel in a group number 1. So these 2 ports are going to be in a channel in group number 1. And the mode, let's set the mode desirable. Yeah, I just hit the tab key. So now it's desirable. As you can see, so both, now they created a port channel. On the interface, it's called port channel 1. And who is in port channel 1? Ports 3 and 4. Is that clear? If this channel 1 is desirable, the other side has to be mode on or desirable. Right? I'm sorry, not on. Auto or desirable. So we'll put it auto on the other side. So that automatically, if he sees the desirable guy on the other end, he'll become also a trunk himself, and then he'll become a trunk. I mean, I'm sorry, a channel. All right, now we got to type no shut to activate both of these ports. We could have done that first, by the way. So type no shut. So now both ports are good to go. Let's go to switch 3 right here and do config T and go interface range FA0/3 to 4. Okay, I'm going to say channel group 1. So make sure it's the same channel. And the mode we said, and we want it to be auto, right? And then you do no shut. That's it. We're good to go. So these ports now should be active, unless I did something. Why aren't they still red? This is 4, 4, 3, and 4, 3, and 4, right? 3 to 4 I did. Oh, now they're negotiating. There you go. So if you go to switch 1 now and type the command show, you know what? Let's do Control Z. Show ether channel summary, and you'll see that here's port channel 1, and it's running this protocol, port aggregation protocol, and it has port 3 and 4 on it. All right, so this is how you can set, or you can type show spanning tree. So if you type show spanning tree protocol. So you see the port, only one port is showing that is connected to the root port, right? Isn't that cool? So it's used, and this is port 6 on the other side. All right, so that's that. That's it. All right. Oh, no, 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 that's not it. Now we got to take the channel and make it a trunk. I forgot to do that. So the last thing that you have to do after you bundle up the channels is you got to go to each, and you got to go to switch 1, config T. Now I go to the interface port channel 1. Now it's like an interface, right? The port channel that has 2 ports in it. And I say switch port mode, you are a trunk. And you say switch port trunk, the native VLAN is 99. Okay, so now I got to go to switch 3 and do the port channel, make them a trunk. So you go to interface, port, channel, interface, port dash channel, 1. Let me exit just to make sure. Interface, port dash channel, 1. And then I say switch port mode trunk, and then switch port trunk, the native VLAN is 99. And that's it. Now you have it. So the first thing you do is get the ports, do a range from 0 to 4, and create the channel group 1, and then the mode desirable or auto. Say no shut, so you can activate the ports. You go do the same thing on both sides, and then you take, now you have the channel done. You got to make sure that the channels are become trunks. Okay? And that's it. Simple as that. Let's do now the LACP and see the difference between them. So let's do LACP between these two switches. Let's do an ether channel using the LACP protocol. So let's go to switch 1. Remember, these ports are 1 and 2. Am I right? Let me just make sure. Yes. So go to switch 1, and this is how you go. This is how you go about doing it. Go to interface range, FA0/1 to 2, bundle them up, and then say, you know what? Here's how they do it. Switch port mode trunk, make it a trunk, and then say switch port trunk, the native VLAN is 99. So just go to both ports and make them trunk, and tell the trunk that spell native wrong. Tell the trunk that the native VLAN is 99. Then you can create the channel group and no shut. So now we're going to do channel dash group. We're going to have it group 2. It's going to be channel group 2 space. The mode for LACP, it's either active or passive. So let's do active on one side. And then type no shut. And that's it. Now you go to the other side and you say passive. You do exactly the same thing, passive on the mode. So you go to switch 2, config T, interface range, FA0/1 to 2, switch port mode trunk, and then switch port trunk, the native VLAN is 99. And then you say channel dash group number 2, and the mode is going to be passive. Okay, and then you have to say no shut. Right? So even once you do no shut, you have to go to the switch one. I never did no shut here. So since we are already in there, I just type no shut and we'll be good to go. And then negotiate and that's it. Okay? It's really that it's not that hard. I mean, we're going to review this again in class. Let's see if you can do the same thing. You do it, but do a channel 3 between these two. Okay, before you submit it. I'm not going to do it. You should be able to do that. Just remember that these two ports are ports 5 and 1 and 5. How did that happen? This is not supposed to be 5. This is supposed to be, which one is that? They're supposed to be 1 and 2. This is supposed to be on 2, not on 5. And this is supposed to be on 3, 2 to 4. And this one is 4 and 2. That's okay. So this is 1 and 2. This is 3 and 4. Okay? So when you group these, just remember it's 1 and 2 and 3 and 4 right here. So you do, so what you're going to do is LACP. So you're going to do range 1 and 2, switch mode trunk, switch port trunk native VLAN 99, channel group 3, mode active on this side, and don't forget no shut. You go to the other side. I'm telling you what to type now. Interface fast Ethernet 0. What is this? 3 and 4. Yes, 3 and 4. Switchboard mode trunk. Switchboard trunk native VLAN 99. Channel group 3 mode passive. No shut and bingo. You'll have your channel and they'll be up and running. All right. So please finish that up, save it, and submit it as homework for week 3. Very simple chapter, right? And this whole week is really just the link aggregation. Next week, we are going to talk about wireless LAN. So this is wireless LAN will take a little bit more time than this, and we'll do also a configuration on that. All right. So until next week, make sure you read your book. And don't forget to finish out your homework. All right. So until next week, God bless.